Um, yeah,
Okay. Morning, Tegan. How you doing?
good.
Hello. Oh, hey, how you doing?
Slow down today.
Yeah. No, a lot of people there. That's all right though. It's it gets toward the end. So. All right. Well, it's almost 9 o'clock, so I'm thinking we should just dive right into this. So we're going to try to get through 3 sessions today. This is real stuff. I think so. Yeah. No, it's.
Are people like quite out of the blue or what?
No, I don't think it's that they're putting it. Just
So,
yeah.
I
there's-
figured in a while or been show up for a while because of sports.
Yeah, that's what I've been hearing.
Yeah.
That there's like events, sporting events and
Yeah.
stuff like that. So,
This could be where the other ones.
all right.
your
Well,
thoughts on the Corbins?
Oh, the shooting.
Yeah.
What exactly?
So the kid had a rifle with something that like stopped the recoil, like cancel that out. There were 4 cops that shot at the same time, and they're on leave right now for the investigation. Apparently he knocked out a window before getting shot.
Wow. Yeah, I didn't hear that. So,
It's like a plane outside or
no. Plane is still. Got to do some little bit of work on it. So, morning, Josie. How you doing? Good. Morning, Trey.
I won again. For shot put.
Oh, sweet. Congratulations.
Yesterday.
Congratulations.
Fairview, shot me for middle school. Got first, 32 feet.
Nice. It's longer than your last one.
Yeah.
Right? Yeah.
Very jealous that you're here.
Great. Thank you much, Jonah. All right, guys, we're going to dive right in. So we've got 3, actually, we're going to go through 4 chapters today. We're going to finish up on the weather theory chapter, and then we're going to dive right into weather reporting and stuff like that. So let's get into it. So we're on chapter, I think it's the 12-18 is what we left off, 12-19 in the books there. So you're going to see this symbology in weather reporting. We're going to get into this in the next chapter, so I'm not going to spend a lot of time at it here. But on maps, weather maps, these little nubs right here, these indicate the warm front. And in this case, it's so in this case, like if this was the front right here, the direction of the front would be in that, going that way right there. So And this is what's called a warm front. If they're in color, they're going to show up in red. Hey, how you doing?
It's this time.
And then cold fronts have triangles on the bars, and in this case, the direction of that cold front will be there. That's called a cold front. And if they are in color, they're going to be in blue. With a stationary front, you're going to have alternating nubs. I call them nubs. I don't know if bumps or something like that. And then these spikes here. Spikes always indicate cold front. Okay. So in this case, you've got alternating. This is what's called a stationary front. So there's no movement in the front. It's just stationary. I'll show you here in a second. Actually, let's go in here. See if we can go here. Okay, so here we can actually see a couple of different fronts, that symbology there. This right here is a stationary front. You see how it's got the alternating spikes and then the lumps on the side there. So cold front and warm front on this side. Cold front here. Again, it makes sense. This is north. You know, we get our cold fronts from the polar regions. So the cold front's going to come from north. Warm front's going to come from the south. This right here, what's this? Cold front. Yep, yep. And then this again, you've got a combination of cold front, and this right here is a stationary area of that front. Here's another stationary front there. Okay. Again, we're going to get into this a little bit more later on too. So, and then an occluded front, which we'll talk about later on. That's when one front overtakes another, and a cold front overtakes a warm front and pushes it out. So what I really wanted to do was talk about to finish up with what this theory was talking about the development of thunderstorms. Thunderstorms, let's see here, typically are going to form along fronts, not always. Sometimes they pop up out of nowhere. But they all have one thing in common. They need a lifting action. So, and they need instability in the atmosphere, a lifting action. They need moisture. Let's see, maybe they've got something here. Thunderstorms. Okay, yeah. So they actually talk about in the book. So if you go to page 12-22, and you'll get a test question on this. It's going to ask you what ingredients are needed to make a thunderstorm. And one of them is instability in the atmosphere, and the other is some sort of lifting action. And the lifting action can come from an upslope on a mountain. Right here, if you've got a front, let's say if you can see this mountain right here in the back right here, as air moves up this mountain, it lifts. It's lifting up the air. It's cooling, and then it produces some instability there because you've got that lifting. You know, the warm air that's got relatively more humidity to it can produce clouds, and it winds up, you know, creating this thunderstorm. So again, instability and the lifting action, the absolute two reasons you absolutely have to have it, and obviously water vapor or some sort of humidity in there. So there are 4 stages of a thunderstorm. So you've got the cumulus stage. Well, actually, 3 stages. What they've got here, I think there's 4. Here. Call it 3 stages. So you've got the cumulus stage right here. This is the building stage. So if you're out, we can't really, like today, we're going to get thunderstorms, but unfortunately they're embedded. We're not going to be able to see them. But sometimes in the summertime, you'll see thunderstorms just sprout out of nowhere. You'll see a towering cumulus like this. It's just, you know, starts building. And if you look at the top of the clouds, you'll actually see it billowing. Like if you look at it for a long enough time, you'll actually see the clouds billowing out the top. And that's the development of the thunderstorm. It's actually in the growth or the cumulus stage is what they call it. It depends on how unstable the atmosphere is. If it's really unstable, it can happen in, half hour or so, something like that. And sometimes it takes longer, but probably I'd say like 15 to 40 minutes in most cases, for it to really develop into something serious. So, and we talked about this before, they can actually get up to as high as 60,000 feet. Here they've got at 40,000. We generally don't see them that often. But 40,000 feet is pretty significant. If it gets up that high, that is usually indicating that it's got a lot of vertical development. And that's the thing about a thunderstorm that makes it so powerful, because it's throwing up all this stuff into the atmosphere. And at some point, that stuff has to come back down, whether it's moisture, ice, or whatever. So in the mature stage, so you've got the development stage right here, or the cumulative stage, the thunderstorm's growing, just again, it keeps building and building. And then eventually it gets to what's called the mature stage. And this is where we get that anvil. So if in this case, if this storm is going in this direction, you're going to see an anvil like this. It's going to start showing clouds over here. That's the mature stage when it hits the top there. And again, what's happening here is it's
Hey Joe.
Yeah.
Would this be like the same like a hailstorm kind of like start?
That's exactly what's happening. And a hailstorm is usually the result of a thunderstorm. So you've got this building, of the cumulus clouds, and what it's doing is it's carrying all the water vapor up into higher altitudes, which is the temperature is warmer or colder up at higher altitudes. Colder, yeah.
So that hail would just be when the hail is produced when the water is frozen.
Right. Yeah. So if you've got a rapidly developing thunderstorm, something that is in minutes, where it's throwing up all that moisture, that water is going to kind of clump together and produce ice pellets or hail. And obviously, hail is not going to float up there; it's going to come down. You're going to typically see that on this side of the storm. So if this storm is moving this direction right here, to my right here, or to this direction right here, it's going to throw out those ice pellets, or those hail pellets on this side of the storm, not so much on this side. Although even you could still see them there, but yeah, you can see these updrafts are just insane. A real mature thunderstorm, or a growing thunderstorm, they can be as high as 6,000 feet per minute, which is a pretty significant updraft. So it's again, all this stuff is building. So think of thunderstorms as weather factories. That's exactly what they are. They're just massive factories for weather. They take all the moisture and stability in the atmosphere and all that energy, and they produce this, the resulting thunder and lightning and rain, hail, and everything that we have to worry about flying. So again, this is the mature stage. The mature stage signifies kind of the beginning of the end for the storm though. That's at the point where the storm is now starting to produce some downdrafts, and it's starting to dissipate. And that's the beginning. This is the dissipation stage. That's the third stage of the thunderstorm. So, and that's where the thunderstorm, it's spent all of its energy, and now it's we're basically releasing it. This is where you see a lot of the rain. You also see in this stage right here, the end of the mature stage and the dissipating stage. This is where you can see things like downdrafts, major downdrafts, like a microburst. So we talked about that last week. What a microburst is. So a microburst is basically a shaft of air that comes down, flows straight down, and if a plane flies into it, it's gonna, the plane is obviously gonna have to increase its angle because air is trying to climb as best it can, because that whole column of air is pushing it down. So that's why downdrafts or microbursts are so dangerous. And again, they typically are going to happen around the vicinity of a thunderstorm, usually on the leading edge of a thunderstorm. You're going to see those downdrafts, so those microbursts on there. So again, dissipating stage. Again, the whole storm is just kind of collapsing. That's where you see, again, a lot of rain. You'll still see lightning and stuff like that, you know, like you would in the mature stage, but dissipating stage after like 15, 20 minutes, that storm is gone. And then another one maybe take its place. So today we've got a great opportunity. We're going to get thunderstorms this afternoon. We've got a line of them. Again, I don't think it's a squall line, but we've got a bunch of weather moving in. So it'd be a good day to just look at and kind of get an idea of how the storms are forming. Just if you look outside and you watch them, you'll actually see some of that stuff. So, so again, you've got the big things there. Again, you'll get tested on this. The cumulus stage or the developing stage of the thunderstorm. That's where you've got, you know, those ingredients. You've got unstable atmosphere. You've got a lifting action, whether it's, you know, the heat from trees or a parking lot that generates it. That's going to produce some lift to the air, and it's going to cause it to rise, and then that mature stage. Any questions? Good. All right. Squall line thunderstorms are essentially they are typically in front of a fast-moving cold front. They are it's basically just a concentrated line of thunderstorms, and they are very intense. I don't just see here if we got it. Yeah, okay, so I think this right here is a squall line right there. So this is heading toward us right now. Let's see. So we're probably going to start seeing some rain in the next, I'd say, half hour, 45 minutes or so, something like that. But this right here is a line of thunderstorms that's moving. Let me see if I can. So if you go on your weather apps and you turn on fronts and stuff like that, you should be able to see this. This here is fronts. Yeah, they don't show the. I'm pretty sure that's what it is. Front there. And again, here's our cold front right there. Very strong cold front. Again, it's coming from the north. It's coming from the polar region, so it's colder, which makes sense, right? We get a cold weather from Canada, and it's coming down. It's probably fairly fast moving. Low pressure right here. You can see. Remember the isobars we talked about last week? There's the isobars. You can see that there's, you know, this is a relatively low area of pressure right here. I don't know if you can see that. Make that out. There's a line right here where the center of the low is, and then you've got the low symbol there. Right? Help us see where that is. So this right here, we're going to see a lot of lightning here in probably the next, definitely within the next 2 hours. We're going to see something in the area here. Okay. Symbology there. Let's go. Yeah, so this is just more talking about, you won't see this in the books, but this is more explains about how thunderstorms develop. So this is the updrafts area. This is the mature stage where you've got updrafts and downdrafts, lots of lightning and stuff like that. Keep in mind, you know, when you have that much energy in the atmosphere, it's going to generate lots of energy. You know, like in this case, it's releasing static electricity, which is our lightning, thunder in there. So, and then obviously the dissipating stage. So a lot of pilots will say, "Oh yeah, I've flown a thunderstorm before," but really, what they're saying is they've flown below a thunderstorm. It's very rare that you find a pilot that has actually flown in a thunderstorm, or, you know, actually right through it. Your dad might be an exception. They have to fly in just all kinds of conditions. So, but yeah, the vast majority of the general aviation pilots, yeah, you get caught in a thunderstorm, especially developing one, and it's going to probably tear your plane apart. And then dissipating stage and precipitation. Oh, Virga, that's a term you might hear. Virga has to do with, it's basically rain. Virga is rain, but it never hits the ground. So what you'll see is if you, on certain days, you know, you'll see some maybe higher clouds, and you'll see streams that almost look like kind of wisps of cloud. They're not really clouds, but it never hits the ground. That's called Virga. And that actually signifies that there could be, you know, pretty severe turbulence in the atmosphere. So you wouldn't want to fly around Virga. So it's basically a shaft of air that's descending, and it's taking all that moisture with it. So that's why you can see it, because you can see the moisture coming down, but it never really hits the ground because it's high enough up. So verget does usually signify pretty severe downdrafts. Yeah. Yeah, here's the amble. This is a really good diagram of the mature stage of a thunderstorm right here. You've got the updrafts, you've got downdrafts, and then there's that anvil shape right there again. Storm is moving in this direction. Roll clouds, that's the precursors to tornadoes. Essentially, they can start in roll clouds and then shift vertically and create tornado. Again, this leading side of a thunderstorm is extremely dangerous for small aircraft, because again, this is where it's going to throw out all that hail to the top of the storm. As the air rises, it cools, the air condenses into water droplets freeze, it gets spit out the top, and it gets thrown out in this direction. There have been cases of hail getting tossed as far as 20 miles away from a thunderstorm. So, and in clear air, you could be flying in clear air and the thunderstorm is 20 miles away. So what is that? Prevail is how many miles away from us? How far is Moss? That's got like 15, 20 miles.
It's
40 minutes. Okay. So it's, maybe here to Laval is the distance, or here to like Sauk. Again, this is a crow flies. That's a pretty big distance. And if you're out flying, like right now, we get up and be out flying and everything is fine, and all of a sudden we start getting hit with hail. And that's the direct result of a thunderstorm someplace that's releasing. So, okay. Again, downdrafts are typically occur in this area right here in this region, but they can occur anywhere in here. Okay. See how development. Again, a tornado, really all a tornado is it's okay. So when you flush the toilet, you see how it rotates, right? It's the same thing in the atmosphere. There's a concentrated area of low pressure around the tornado. It gets it to start sucking up air, and it's because of the atmosphere and the way we are in that Coriolis force that we talked about. It causes it to generate a rotational force on it in the atmosphere, and then it causes that twisting action. Yep.
will the tornado have like its own kind of pressure?
Yeah, it's probably gonna be much lower than the surrounding area, but that's by virtue of the fact that it is in a low pressure system. And it probably would create more low pressure. I don't know the exact physics of it, how that actually works, but I know like in a hurricane, if you look at look at maps of hurricanes, weather maps of hurricanes, look at the center of the map. They always talk about the eye of the hurricane. That's the area of the lowest pressure. And it's, so low in there, there's so much rotational velocity that it leaves this eye there in the center of the hurricane of extremely low pressure. But next time you look at a weather map and there's a hurricane, look at the center and look at the symbol in the center, it's going to say a low.
That's why I was going to wonder about the tornado.
Yeah, it would be very similar to that. But I don't know if it gets worse because of the tornado or if it's caused from the low pressure. That I don't know. So, okay, any questions on pressure? Yeah.
Why they put just about what amount to general, but why number is this low? Why is it in red? So like the rest of it.
Oh, yeah, that's a good question. Yeah. So I think what they do is it helps us identify areas of low versus high, cold versus warm. So if you look here on our map, we can see low versus high pressure, relatively high pressure. And then also we can see cold, which is blue, versus warm, which is red. And I think they put those colors in there just to help us identify that. I can just glance at this, and anywhere I see red, okay, that usually indicates low pressure. And that's what we're going to have for we have some low pressure areas here. We've got 3 centered here, but this whole area is in kind of a low pressure trough almost. And then you've got a high pressure area right here, and another one. Let's see right there. So, and notice how the weather up here is really nice and nice. So this high is it's relative to this one. It's a little bit higher, but all the lows are producing all the bad weather. That should give us a good indication of of how low pressures versus high pressures work. Low usually results in potentially poor conditions. Not always. We get low pressure systems and the sky is sunny and stuff like that. A lot of it depends on how much moisture is in the atmosphere and how unstable the atmosphere is. Okay, any other questions? Okay, so let's go to aviation weather services. And this is 13-2. Okay, so this we're going to talk about several different types of weather reports that you as a pilot can look up to kind of see, you know, what are the conditions? Is it safe for me to fly today? So the things you need to remember from this, the main takeaway from this is that there are two primary types of reports. There's an observation and there is a forecast. Observations are merely that. They are just observed weather conditions for a city, for an area, for an entire region. So it's an observation that somebody looked at, or you've got a sensor out there that's observing the atmosphere. So that's one. The other one is a forecast. Those can be generated by a computer, but they're oftentimes generated by a human being. Nowadays, we're seeing more AI in aviation, so we're starting to see some more AI forecasts for aviation. They've got a bunch of different models that they can't even remember the different names for that take all the information in the atmosphere and they produce what they think is going to be a forecast for, you know, the weather. And it could be a forecast for a week. It could be for just 2 days. It could be for 2 hours. So forecasts vary in length, and it depends on, you know, what you're trying to do. You, as the pilot in command, are going to have to determine which reports are most relevant to you. So if I'm going up right now, and I know I'm not going to be flying for more than a half hour, I'm not going to be worried about a forecast for tomorrow's weather or even this afternoon's weather. I just want to know what is the weather going to be like for the next hour. You know, here I know I'm going to be flying 15, 20 minutes. So my concern is, you know, what is the weather going to be like for the next hour? So I'm going to be focusing on forecasts that are a little bit more local to Reedsburg and, you know, how it can impact my flight. So weather checklist here, these are just things that, you know, you might want to be aware of. We'll go through all of these. So WX, by the way, if you didn't know that, WX stands for weather. That's our shortcut or abbreviation for weather. So synopsis, usually synopsis is kind of like a forecast. It's just basically a way of presenting to you information about what the weather is kind of doing, what they think it might do. That's what a synopsis is. So it's kind of like a forecast, whereas observation, wherever you see the term current, that means it's some sort of based on observations. Okay, forecast is exactly that. It's talking about forecast weather. And again, this right here, destination weather forecast, winds and temperatures aloft. We obviously need to know what the winds are, because if we're flying, and let's say we're flying east right here, and we've got a headwind that's, you know, 40 miles an hour, and our plane only flies at, you know, 80 miles an hour or 100 miles an hour. That's going to slow us down. We're going to have to plan for more fuel or fuel stops to get to our destination if it's a really long destination. So winds aloft, that's called winds aloft. That's going to be something, obviously, you're going to have to know how to read those information there. And I'll tell you now, we're going to get into it in a second, but back in the 50s, 60s, 70s, even the 80s, when I was getting into aviation, they were really cautious about how much information they put out. And what I mean by that is we didn't have the graphics that we have today on the internet. Today, the internet's just amazing. For pilots, it's been just fantastic. Back in the old days, they used to have these teletype machines. You ever heard of a teletype? So it's basically, yeah, it looks like a typewriter. Like, I don't know if you even know what a typewriter is, because it's like, so it's a typewriter, but basically it's an electronic typewriter. And what it does is it takes signals from the outside world, and then it starts typing the words out. And because it was so costly to produce this, you know, you had to send a stream of data to these teletypes. and they would type out this information. Well, because it was so costly to do that back then, they had to abbreviate everything. This is what we're going to see today when we look at the weather reports. Now, fortunately for you, once you get past the private pilot, and then if you decide to go with your commercial and ATP, you're going to still have to know these things. But if all you're doing is getting your private pilot's license, after this, you can go to your smartphone and I can bring up all the weather here that's decoded and everything. It shows me everything, and I never have to use codes. I personally like the codes because it's another way of reading information very fast. Let me show you what I mean by that. Okay, so let's see. Yeah, here, let's just get into the categories. So observations, some warnings. Again, these are the different types of reports. METAR is a term you're going to hear a lot of. PIREPS, that's a pilot report. Ceiling and visibility reports. TAFs, which stands for terminal aerodrome forecast. That's a big one. The ones you almost are always going to use are METARs and TAFs. There's a lot of these other we call them weather products that describes those. Then there's all these forecasts here. We're going to go into each one of these here in a second. So let's see here. All right. Let me just do this. I'm just going to bring out a METAR. Okay, so this is an example of a METAR right here. This is for the Baraboo Dells Airport. It looks like a bunch of gibberish when you look at it. Yeah. Well, actually, let's see if you can Zulu. Yep, 6 knots. Do you know what the direction is there? 140 degrees. Yeah, you guys are already getting it. Okay, perfect. So let's break it down here so we can actually see. This is an observation. First off, let's take a look at the first item in there. It's KDLL. That's the ICAO identifier. That's the international identifier for the Baraboo Dells Airport, KDLL.
So although there's 10 miles of visibility, how was it clear? I thought it was like overcast.
Okay, we'll get into that. Yeah, it's a good question. So let's take a look at this. So KDLL, what this first segment here is basically our time. And it's actually, there's a couple components to it. There is this first 04, that's the date. So today is May 4th, right? So it's going to say 04, that's May 4th. See if I can zoom this. See that there. So this right here, that's May 4th. This is our time element or timestamp for the observation. Again, this is not a forecast, it's an observation. Then this right here is our time in Zulu. That's what the Z stands for. Now you look at that, and you say, well, that doesn't make sense. 13:15 Zulu. Right now, what time is it right now? It's 9:30. But Zulu time is based on Greenwich Mean Time. So our UTC, what we'll call UTC time, Universal Time Coordinated. So in aviation, we don't use our local time. When you're talking to ATC, you never say I'm going to arrive at Madison at 9:30 a.m. You don't say that. You're going to say I'm going to arrive at 13:30 Zulu, something like that. That would be the Zulu time. Again, that's how we say time in aviation. So in the Midwest right here, we're 5 hours behind Zulu time. So right here, this observation, oh, actually, this is old. The latest, this is the current. So we're dealing with, okay, so here's a current METAR right now. Let's see how it's changed. Let me zoom in on this a little bit. Okay, so again, there's our date, the 4th, May 4th, KDLL, Baraboo Dells. 14 is actually 9 o'clock. So we subtract 5 from the Zulu time to get our local time, in this case, 9 o'clock. And it's military time, so it's always 24 hours We don't have AM or PM on there. It's always military. But again, because we live in the Midwest, it's a 5-hour difference. Okay. So we subtract 5 hours from this to get our local time, which is again 9:30 or 9:15 in this case is when this was reported. So now let's break it down. So we've got this first element right here. This is our wind element. And this is the way it's always going to be presented, whether you're going to, Denver, Los Angeles, they have the same reporting structure. They always have these elements. You've got the timestamp, you've got the wind element right here, and it starts with the direction. That's 150. So what direction is 180? South, yes, okay. This 150 is essentially southeast, yeah. And that's saying the wind is coming out of the southeast toward us, okay? The wind isn't going in that direction, it's actually coming out of that direction. So 150 at 8 knots. And then you've got your statute miles. This right here, 10 SM stands for 10 statute miles. That's our visibility element right here. And then, so you've got winds element, visibility element. Then the next element is cloud conditions, sky obscurations. In this case, it's clear. So if you go over to Bearwood right now, there's no clouds up to 12,000 feet. So that answers your question. You said, well, is it, let's say it's overcast out. Well, the way the AWAS, they have an automated weather observation system there. I think Reedsburg does it too. It only reads up to 12,000 feet. If it doesn't see any clouds up to 12,000 feet, it just says it's clear. Most of us are going to be flying as, private pilots. So we're only concerned about, altitudes that we would typically fly in. So they report it as clear. And the other reason they do that is because most of the time when you're reading a METAR, it's because you want to land there or maybe possibly land at that or take off from that location. So you're not really concerned about clouds that are super high up, like at 20,000 feet or something like that. You're really more concerned with the clouds that are close to the ground, that could be a problem if you're coming into land or take off. Okay. You may want to take a guess at what this means right here. Yeah, it's temperature dew point. Yep. So you've got your temperature, 16 degrees Celsius now. Okay. It doesn't make sense. If we were to say 16 degrees Fahrenheit, it's definitely not 16 degrees Fahrenheit out there right now. So, but it could be 16 degrees Celsius. So just remember that these are all, everything in aviation is in degrees Celsius. You will not see anything in Fahrenheit.
It's the metric system.
What's that?
We don't there.
Well, we do in some areas.
Some areas?
Yeah, so, but yeah, it's, as far as metric versus, imperial, it has to do with aircraft manufacturing. We get into in navigation side, we actually do a flight over. So, but again, in weather reports, you're always going to see temperatures reported in Celsius. So the temperature is 16 degrees. The dew point is 9 degrees. Okay. Does anybody remember what the dew point means? What that means?
That's what water condenses it. Like if it's the same, it's gonna rain, or like lower it will.
Okay. Anybody else have something? That's you're close. Yep.
Like the temperature water that's at.
Yes, that's exactly what I'm looking for. It's when if we were to take the air that's in this 16 degrees right here and chill it down to 9 degrees, we'd actually expect to see visible moisture or rain, which is like what you said. It's the same thing. So, but the way the FAA defines it, the way most meteorologists describe it as, it's the point at which water will start condensing. Okay, that's the dew point. Okay. Anybody want to take a guess at what this is? It's almost, you can almost read it and it makes sense just by looking at it. So actually, the only thing we're missing here is a decimal point right there.
Oh. Air pressure.
Yes, yeah, it's a barometric pressure, and this is in inches of mercury. So it's we can tune this in when we see that, and we're in our plane. We can just tune our altimeter, adjust the barometer that pulls in the window. We just adjust that to read 29.93. So that's the pressure. Now we've got all these weather systems moving through. the course of the day. So the pressure is going to change, and it could change really rapidly if we've got these storms coming in. If we come back here another half hour, right now, let's just make a mental note of this. The temperature or the altimeter setting is 29.93 inches. So let's remember that for later, and then we'll come back and refresh this. Actually, let's just refresh it. Just see what we get. Just want to see if it changes at all. Because it can change really rapidly. Okay, yeah, it's not there. So, these are the main elements of the METAR right there. Timestamp, the weather group, again, distant, or the direction that's coming out of, and the speed of the winds there. And then your visibility group right here, and then cloud obstructions. What I try to say here, clouds and things like that are going to be shown here. This obviously we don't have much. If you look down here at Madison, however, their METAR is starting to say few clouds at 014, and that's at 1,400 feet. That's what that stands for. So any altitudes here that you see in these reports, these METAR reports, always add or multiply by 100. So in this case, it's saying a few clouds at 1,400 feet. That is. Again, few clouds at 15,000 feet, broken at 25,000 feet. That's what that's saying right there. So this is our cloud right here. Again, sky obscuration, I guess is what we would call it. And then same thing down here, temperature dew point. There's our barometer right there. And then you have these other things here. So this right here these are remarks that some AWOS stations will add in there. So what this is saying is remark, this is a AWOS 02. Light LTG is a contraction for lightning. Okay, and DSNT is distant, and then W is just an abbreviation to the west. So that remark is just giving you a little extra information. Again, it doesn't really pertain to Baraboo because the lightning is way off to the west, but they thought, we'll add this in there in case they're, arriving delayed. Maybe I'm coming from Green Bay, for instance, or maybe Detroit, and I read the METAR and I see this. Okay, it looks like there's lightning distance to the west. I would be a little concerned that maybe there's a thunderstorm that's starting to move into the area there. On that, this right here is precise measurement. We won't get into this, but it's a precise measurement of temperature there. And it probably won't use it. It has to do, or is it pressure? Things there, but again, it's not something you typically would use. It's something I think more weather forecasters would use. It's a very precise measurement. And so, again, Madison. Here's the TAF for Madison, and KO identifier, time group, wind group right here, visibility group, and then you've got your cloud group. And again, it could be several different layers there. Temperature dew point right here, altimeter setting, and then remarks. They oftentimes will have, let's see if we can do, so here's Volksfield's METAR right here. Again, there's the time group right there, timestamp, there's the wind group, visibility, and then we've got our clouds, aspirations there. So broken at 14,000 feet, overcast at 18,000 feet. And that's what we're probably seeing up there. Take a look at that. That's we're probably seeing between 14 and 18,000 foot ceilings there. Temperature dew point, altimeter setting right there. So the altimeter setting, it looks like it's a little bit to the west there, or to the west of us. See how this is lower than these other ones, right? This is 2194. Volk is west of us, a little north. So the low pressure is close up there. Yeah.
What is this?
Oh, sea level pressure. Okay, so that's good. That was good. Good thing you brought that out or mentioned that because I wasn't going to even say anything about that. So you'll find at most airports that have military traffic, they're going to report sea level pressure in hectopascals. So you're going to see it instead of inches of mercury like this right here. They'll do the sea level pressure right there. It's actually 1,100. Before I never use it. We measure it in inches of mercury. They measure it in I don't know millimeters or something like that. I don't know. It's like 1,000. So you'd actually, what you would do is you'd add 1,000 onto this, and it would be 139 millibars or millibars, I guess. Yeah. So again, for military traffic, they're going to use that. They're going to use that. And actually, over in Europe, I think we're the only country that uses inches of mercury. So we report everything. Our altimeter settings are always like this. But if you go over to Europe and fly there, they're going to give it to you in millibars. Right. Let's see. Okay. Let's go back here. All right. So that was METARs right there we went through. Again, observations, warnings. We've got all kinds of forecasts in here. Let's go here. So this site right here is essentially free. You can actually sign up for this. It's WX Brief. And actually, this is the one site I was just on. It's 1-800-WXBrief.com. You probably want to get registered on that site, just so you can get familiar with all the different weather products. It's got a ton of information on it, as far as weather information for pilots, and it's basically to help us understand the atmosphere. Is it safe for us to fly? And you won't understand everything. I mean, there are very few pilots that do understand all the different facets of the different weather products, but you need to start getting familiar with it, so you know how to read various charts and things like that. So, so this is just a picture of it, but let me just go to the actual site here. So if I go here, and it has changed over the years too. So you can bring up things like weather charts. This is a 24-hour significant weather prognostic chart right here. So it's prognostic is something that somebody thinks is going to happen right here. So they're prognostic and diagnosing. They're saying that the weather is most likely going to be like this. Now, anytime you see a chart, a weather chart, they're always going to have something related to the date it was issued and the date it's valid for. Okay. The one thing you need to know about weather forecasts is the more recent the forecast, the more accurate it's going to be. If it was a forecast that was done yesterday for today, it's going to be less accurate. Okay, that's one that just makes sense, right? Right now, I could say, all right, well, I know that there's a bunch of thunderstorms off to our west. I can forecast that within 2 hours we're going to see thunderstorms here. Okay, that's a short-term forecast, and it should be pretty easy because you can see the thunderstorms over there for observations. But if you were to say, hey, Joe, what is the weather going to be like next Saturday? Well, now I've got to figure out, okay, well, I don't know what the conditions are going to be. I'm going to have to make a guess at it. So long-term forecasts are also going to be less accurate. The shorter the term, the more recently that they're forecast, the more accurate they're going to be. Okay. So, and that's true in anything in meteorology. They have a much better idea of when these storm systems are going to occur when they're really close, within a certain amount of time, like a couple hours, and they can tell us, yeah, well, we're definitely going to get thunderstorms now, and we can see it if I look at the current radar. See if we've got. So this is weather bug. I don't know if you guys use that there. Look at all that weather right there, and that's moving our way. We've got a forecast right here. So we're right here. So yeah, probably within an hour we're going to get hit with some pretty good thunderstorms. I'm guessing there's a lot of like. So yeah, there's a line of thunderstorms here. You can see it. You can see the yeah.
Because you look at the
Oh yeah.
Like the cross extension. Extension.
Which
It's one that had like the signs for the overcast. Like next.
This one right here?
Yep, no, they're right.
Sorry, this one right here?
That.
Oh, gotcha. Yeah, that interactive. Oh, they yeah, they do get a little bit here. So this is actually showing you could so this is another type of map here. So just let's get our bearings. Okay, there's northern Wisconsin. There's Minneapolis right there, and the cross should be around here. So yeah, there's the cross. Okay. So what we're going to do is we're going to click on this right here, and I'm just going to turn on VTARs and tabs. That'll give us dots indicating where there's IFR and DFR. So a blue dot right here is indicating marginal IFR. Red dots indicate IFR. So they're obviously getting some weather there. Let's look at radar here. So they're probably, yeah, that's all. That's rain showers right here. So that's what's happening over there. And then if you look further and zoom out, see how it's pixelated? That's just the way the weather radar works there, but at least kind of gives us an idea of what's going on there. And then we're over here. Yeah, we're right here. So it's starting to get close to us now. We get some rain showers north of us. There's some light rain showers that just pass through here. But all this stuff right here is probably moving in our direction. So I can do forecasting. Okay. This is about 1 hour here. So it's moving pretty quick there. That's just another service in this W. TFR, you're doing TFR stands for?
Yeah.
Yeah. So those are obviously, we don't have to worry about that for weather, but you know, before we fly, we want to know if there is a TFR. We actually get into that in the when we talk about.
Do they all use it for like military? Like
it could be used for sporting events. We have Badger games. They have a TFR on that. I think we still do it. Obviously, Packer games. They have TFRs. There's I think a permanent TFR over each nuclear power station. The TFR over there. And what they are is TFR stands for temporary flight restriction. But essentially what it is it indicates that you cannot fly in that area. When a president comes to visit Wisconsin, they'll have a TFR over the area that they're at, which means no flying. You can't fly over them. It's just a restricted area for a temporary period of time. So let's go back here. So again, observations, forecasts. VTAR is a product that is an observation. So let's go here. Some other ones, yeah. Radars. There are different types of radar here. Let's get into. So generally speaking, when it comes to weather radar, the redder it is, or the more purple it is, the more dangerous or intense it is. I've been in obviously green, the blue areas, usually just light rain. Green, starting to feel more rain. When you get into yellow, you're starting to get into some pretty strong, rain. You really hear that when it hits the aircraft, especially if you're going really fast, you really hear it. It's very loud. The red, I would never ever consider flying in, and I would do my best to avoid the yellow areas. It's probably too much convection in there. Atmosphere is rolling and stuff like that.
So that'd be like the road would be like a storm. So
it could be. It could just be an area of an intense intense downforce. So what's happening is, if you look at a radar, what a radar does is it sends out a beam and it listens for it. So there's a device that swings across, and it's sending out a beam, and another receiver that receives that reflection. The stronger the reflection that's coming back at the radar, the more intense this line is. It's like if I were to point it at a wall like this, a radar at that wall, I get a really strong bounce back. Like if I yell at that wall, it's going to echo back at me. For a big building, it would make more sense. But whereas if I just am standing outside and I just shout, my voice is just going to keep carrying. It's not going to bounce back from anything. It's all in all area. That's essentially the principle of how a radar system works. It's setting out pulses of energy, electrical energy, electromagnetic energy anyway. And then when it hits something like sound, like, a cloud, rain or something like that, it bounces back. The faster, or I shouldn't say the faster, the stronger that signal is when it comes back, it's indicating this is more intense. There's more rain there. So that's what these different colors signify, is how strong that echo is. And they can actually be difficult sometimes to interpret. If you've got a really intense line of rain, the problem that may occur is that the echo may hit that rain and bounce straight back and show an area back here that is totally clear, when in reality it's solid rain. So that's one of the drawbacks of rain or of radar. That sometimes you can get those situations. That's more with like onboard radar on aircraft. You have to be really cautious with that. Obviously, when we look on the ground, we look on our websites here, they are using what we call composite radar. So they're looking at, they're actually compiling weather radar from several different sites, and so they can see the backside of storms. And so we wouldn't see like a hole in here saying that it was clear, but really it's very intense there. These are some of the different types of modes for weather radar. Again, we don't really have to get into this right here. What we're mostly concerned with in general aviation is how intense the precipitation is, whether it's ice, snow, rain, whatever. We want to know how intense it is. So preferably, we prefer not to have any, even some of these low returns right here. It's still going to be significant for some pilots that fly through there. So radar reflectivity, that's just what I was talking about. This is how strong the returns are. So a light return obviously means that there's probably light rain at that distance, or just light right there. Whereas moderate return, that's going to say, all right, well, I'm starting to get a stronger signal, so there's probably more moisture in the atmosphere, more rain or something like that. An extreme, obviously, that would be very intense rain. So that's how radar works. Okay, a couple of different types of weather reports, like on your sectionals. You don't have to bring them up now, but you'll see these VOR boxes, which we do get into later on. This little symbol right here, that H stands for high watts. I think they're starting to phase some of these out. I know they're phasing out a lot of VOR stations, so we're seeing less and less of these. But H, if you do happen to see that on your sectional map next to a VOR station, that's what a VOR symbol looks like right there. You see that means that it has a, if you tune into this frequency right here, you'll actually hear weather reports up there. And hazardous in-flight weather advisory services. So here are some of the different contractions. Again, I'm not going to go through all this stuff. This is just one of those things you guys will have to start reading and, like the rest of us, get comfortable with. So they do have cheat sheets you can get online that show this. There's this one here in your book you can look at. So contraction right here, BC usually indicates it's in the vicinity of the descriptor right here. This describes the type of the item, weather phenomena. In this case, shallow patches, low drifting, blowing. So like blowing, it obviously would pertain to like snow. BC could pertain to snow and rain. SH could be snow or rain, snow rains or whatever you could apply to. It's a descriptor for the type of precipitation. Okay, so when you see that in a report, you'll know what that means. That's for. Again, this is where it's helpful to actually look at real reports to see what they're talking about there. Obscurations there, I should say precipitations. You've got drizzle, which is designated as DZ, rain, which is RA, that's easy one to remember. SN, snow, SG, snow grains. We don't see that very often. It does happen. I've seen it maybe twice in all years of flying. So icy, ice crystals, PL, ice pellets. Again, it's another one of those things I really don't see. GR is hail. And again, because they don't fly when there's thunderstorms, at least embedded thunderstorms, they won't fly. If there's isolated thunderstorms, I may consider flying as long as I can always see them. But if they're embedded in clouds, it's too risky. So for me anyway, now maybe there's another pilot that would feel comfortable flying in if they've got the right kind of equipment on board the aircraft. They may feel comfortable flying through. But anyway, GR stands for hail. GS, small hail or snow pellets. And UP, unknown precipitation, because you probably won't see this very often. So there's only a couple that you're going to see on a regular basis: drizzle, rain, snow. You might see ice pellets. Those are the prime ones. So like these three right here at the very top, those you're going to see those contractions a lot. So obscurations, these are basically obscurations for the atmosphere. So a mist, think of mist as baby rain. It's BR is a contraction for it. Think of mist as baby rain. That's the term to use for it. Fog, that's easy enough to remember. FU, smoke. DU, dust. Again, we don't have to worry about that so much around here. SA, sand. HZ, we see a lot in our weather reports. PY, again, that's probably more for coastal regions. Again, VA, volcanic ash. Again, these are all obscurations to the atmosphere. These are obscuring our visibility. You may see this again in areas where there's volcanoes, not in Wisconsin. So you're in Wisconsin, we're typically going to see things like mist, fog, and haze. Those are the most common ones here in the state. And then other types of obscurations or weather phenomena, dust samples, squall lines. That one's a big one. We do see those occasionally. FC, funnel cloud, plus FC, tornado, water spout, sandstorm, dust storm. We don't see this much. But again, we need to be aware of them flying across the country where they do exist. We need to know those contractions. Any questions so far? So I'm flying through this there. I'll tell you what, let's take a quick 5-minute break and then we'll come back and we'll continue on with this here. So in a second, guys. Close this door. Yeah. Okay, let's get back at it. Okay, so for font type descriptions, there are these are the basically contractions that describe sky conditions. So SKC stands for sky clear. CLR again, it's contraction for clear, so that means blue skies essentially. Few, there are going to be some clouds in the sky. So essentially, all of those describe a coverage of less than 1/8 of the sky. So if you look at the sky at any one time, there's 1/8 of it that's going to be covered up, or less, with clouds. I mean, these three right here. So 1/8 to 2/8 or a quarter of the sky, that's be listed as few. So it's listed as FEW right here. Scattered is 3/8 to 4/8. Again, that's almost up to half of the sky is covered with clouds. And then 5/8 to 7/8, that's going to be broken, and that's actually the line right there where broken or overcast is considered a ceiling in aviation. And what a ceiling is, it makes more sense in the context of regulations. So as VFR pilots, we can't fly, in conditions where the ceiling is less than 1,000 feet. That's considered IFR. Over 1,000 feet, you can fly it legally. So, but the ceiling, the definition of the ceiling starts at broken and then overcast. Those are both considered ceilings. And again, that has more to do with regulations. And again, 5/8 to 7/8 of the sky is covered in cloud. 8/8 again is completely overcast. So if we look at here, we can say that it's overcast. But here's the thing: that overcast layer is really high. So we could still fly right now legally. There's nothing wrong with it because the ceiling is so high. It's maybe 10,000 feet, something like that. It's starting to get lower here as that weather system moves in. The ceiling is going to keep dropping lower and lower until we get the thunderstorms, and then all of a sudden it's going to open up. Blue skies later, or it'll probably clear up. That's what I'm guessing. So, right, that's sky cover and the contraction for it. All right. Pilot reports. So again, this is a type of observation. So pilot reports, let's take a look at that here. Okay, so this is on page 13-8. Pilot reports are exactly that. They're a report by a pilot. And what they are, they essentially are an observation by a pilot they could be at 20,000 feet, they could be at 10,000 feet, they could be on the ground someplace, but they're observing the weather. And it's very underestimated how useful pilot reports are. If you're flying, let's say from here to, let's say we're going down to Kentucky or something like that, and you want to see, if you look at the weather, let's say, so we go here, zoom over here, let's do this. So we're flying down to Kentucky. I don't see any weather down there, but let's say a pilot somewhere over here is running into a lot of turbulence. They're going to report that on their when they do a report. Well, they may report it. Hopefully, pilots when they're all flying will give a ATC condition reports or these pilot reports. What's that? Yes, there are. Yep. Mm-hmm. If I go on the layers here. I'll show you. Probably, unfortunately, there's a few of them here. Okay, so like these little symbols right here, these are the indication that there's a pilot report. You can see it looks like a little caption right here. So let's click on this one. Right here, they're saying nothing intense here. So the UA is the designator for pilot report. And then the /OV that says what they're over, the location that they're at. That starts, and so in this case they're over Indianapolis. I'm thinking there. And then the TM, you can probably guess, that stands for times. That was done at 1458. So that was pretty recently here. And then flight level during descent, I think it's the contraction there. So FL stands for flight level, and DURD, I'm pretty sure that means during descent. And then the type of aircraft, I don't know what that is. It's probably an airliner, I'm guessing. And then the SK, this, I'm sorry, TP is for the type of air. This Airbus. SK, that's the sky conditions, and that's going to give us, you know, the I can't read that. I don't know what that is. I can't details of that. Numbers obviously have some significance for us. I can go back to it here. So here. I think that's just the sky conditions. And obviously you can get this stuff decoded, which is what most pilots will do.
Sky cover.
Sky cover, yeah, sky condition, yeah. So it discovers the height of the cloud base in hundreds of feet. If unknown, use unknown cloud cover symbol, height of the cloud tops in hundreds of feet. Okay, yeah. So they're with let's go back to that again. It's like, yeah, as you can tell, I don't use these very often, which I should. I do report them though. Chance. Oops. Okay, sky. Oh, that's turbulence. So that actually is reporting that there's, in this case, it's moderate turbulence. This right here is reporting light turbulence here. So, yep.
So what would be the red arrow on the wheel at the top?
This is again, it's going to be turbulence there. So let's go through it again. UA stands for pilot report. It's over this identifier, which is running VOR station. Actually, this right here describes the direction and distance they're away from that. So they're the 265-degree radial, 8 miles away from this VOR station. I can look it up on here. It's probably this view over. Yes, it's this view over here. So this is where it's nice to know the area there. So this, so over is again, it's the location. So SZL is a VOR someplace, and I don't know. Oh, here it's got
Warrenburg? This is close to it.
yeah, we're looking for an airport that has, or yeah, yes, they have different code names for a lot of this stuff. What's that? Yeah, yeah, like, they're really good for this. So in any case, this right here is the location there. So this right here is going to be your airport identifier, or it's going to be a VOR identifier, but it's telling you a location. And then this right here is two sets of numbers. It's the direction that you are and the distance you are away from this location right here. That's what it's showing. Right? Does that make sense? Okay. And then time, again, this is our time in Zulu, 1410. Flight level, what is that? That is 14,000. 14,000 feet, correct. Yeah. Again, we always multiply our altitudes that are shown on here by 100, and that's going to give us our altitude. So type TP, it's a GA5C, that is. TV, turbulence. So remember you'd asked, well, what is that symbol? So this is saying continuous light to moderate turbulence. Looks like it was during descent. During climb. Down here it actually says direction. So this is one of the reasons why it's sometimes harder for pilots to use these, because they're all contracted. Now, obviously, I can decode this and get this, you know, but it's nice to be able to know these different contractions. You know, they're So, but again, this is just describing, in this case, this person was experiencing light to moderate turbulence in this area right here. So that would be nice for us.
That they're, I think it says that they were experiencing that at like 1700.
I don't think so. I don't think that way. If there was altitudes, it would be 17,000 feet. So in this case, the flight level was, oh yeah, okay. So it's from 17,000 to 14,000, probably during descent. Again, 14,000 mark, and then these other remarks are not quite sure what those mean there. So, but again, you're going to be able to pick up a lot of information on here. The thing about pilot reports is that they're not oftentimes, you don't have to fill out everything out of pilot reports. So if you call up ATC, you don't have to report all of this stuff to them. What the FAA really wants you to do is to report conditions that are not expected. So if I'm out flying my plane and the forecast was for clear blue skies, and all of a sudden I run into a thunderstorm, well, that's a big change from their forecast conditions. And it would really be helpful for other pilots to know that, because they're going to be basing their flights off of forecast, conditions and not what's actually in the atmosphere. So when pilots, have this, information, they report this, it's like another set of eyes for ATC, and it helps them understand, what the weather's doing. Because forecasts are great, but like I said, the further out a forecast is, or the further in the past it was generated, the less accurate it's going to be. And ultimately, the best observer for weather is somebody that's actually up in the atmosphere, measuring the temperature. Every aircraft is going to have a thermometer on it. We have a temperature gauge, so we can see what the outside temperature is. We're going to know what's going on here. So here's another example of a UA. I won't get into this too much more, but I want you to see this. So in this case, OV is again our location identifier. Over Oklahoma City to Tulsa, somewhere in that area there. And seeing time was at 1800 Zulu. Flight level was, you know what this is? 12,000 feet. Yeah. Type is H90. It's a King Air SK 180. You know what that is? Sky. Okay, so first off, the slash SK is just talking about sky conditions. Any kind of cloud conditions and stuff like that. That's all it's specifying. This right here is what we're concerned with. So this right here is saying 1,800 feet broken. So that's the base of the clouds. And the tops of the clouds, 055. That is 5,500 feet. So I would, if I was flying in this area, I'd expect to find clouds from 1,800 feet to 5,500. Okay, so the bases are always going to be on this side. Then the type of cloud it is, scattered, few, broken, overcast. Those contractions will go here, and then the tops. Not always, because maybe the pilot only flies into the bases and never flies out the top. But in some reports, you'll see the base, the cloud type, and then the ceiling, and then you'll see another one. And then another one, because the pilot's flying through all these different layers of clouds. So any time on a UA or a pilot report, you see a slash and 2 characters, that's describing what you're about to read. Okay. Anybody know what this one is?
Icing.
Yep, it's icing and
Light and mild.
Light to moderate. Icing. Light to moderate. All right, I think you guys got that. Any questions on pilot reports? Okay, there's another type of one. This one's decoded right here. There's the report here, and I think this is in your book, if I'm not mistaken. Yeah, they do have an example. So again, get familiar with these. Actually go to that FAA website, or the 1-800 WX brief, and get on that site so you can start looking at these weather reports to be comfortable with them. The more comfortable you're with them, the more you understand them, the more likely you're going to, ace this part of the test here. Okay, so let's here. Go over some of this stuff. Guitars. Yeah, we've already gone over this guitar reports. There are a lot of really good uh, sources on the internet to interpret this information. So if for METARs, again, we use pretty much the same types of contractions that we do in a lot of the other weather reports. Now, another type of forecast is what's called a terminal aerodrome forecast, or a TAF. That's what we refer to it as, a terminal aerodrome forecast. This is on page 13.9. So a terminal aerodrome forecast is essentially, it comes from an airport. So like Madison, they've got a meteorologist at the Madison Airport, and their job is to do continuous forecasts for the airplanes flying into Madison or flying out of Madison, so that pilots will know what type of weather. They're not concerned with weather outside of Madison. They basically are concerned with a 6 nautical mile bubble around the airfield there. And what they do is they'll write up a report or a tab, and they'll have all of this information in. We'll get read one here in a second. Yeah.
Is that why airports will have those like red circles around them on charts?
So yeah, you're talking about like these are observations actually. So let's turn these off here. Let's go back to layers. I'm just going to turn on METARs and tabs here. So what you're going to see here with this is, let's zoom out here. See, now you're talking about these right here. That's right. So
No, I was talking about the red bubbles around the actual.
That's the actual that's ATC. Like that's how far their radios go until you're free on the actual air.
you're talking about like these magenta circles right here.
Here, can we go to okay?
Yeah. Here is a class Bravo airport. So it's a very busy airspace. You're talking about these blue lines right here. Is that kind of what you're thinking? Yeah. Those are describe the airspace, which we'll get into in another session here. I think next week we dive heavily into airspace navigation. There's Milwaukee right here. There's Madison, magenta. These are all listed magenta. So magenta and blue are pretty much the colors of sectional maps. So let's go back to tabs. So TAF is going to have all this information in it. These are the details on here. And again, you should be able to see this in your training materials. They actually go through it, I think, one item at a time, one element of the report at a time. That's on page 13-9. So let's look at a couple of TAFs just so we can kind of decode what a TAF, what it presents to us. So again, a TAF is a forecast. It's not an observation, it's actual forecast, right? Let's go here. Let's go to the dashboard. Okay. So this right here is a TAF for Madison. So this is the whole block right here for Madison. Again, everything is compressed down into codes, and that's so we can see all of this stuff, just by glancing at it. They could spell this out, put out in plain text. But look at this. Okay, so this is what we have right here for the coded version. Let's look at the exact same version in plain text. So we've gone from basically from a single line to all of this essentially. Taken all of that and expanded it into this. So it takes up a lot more text. Let's go back to plain text here. I'm sorry to code it there. See how it's just one couple lines here of text, so you can instantly just glance at it, and if you're looking for winds, you can see, okay, well, can look for, you know, winds with the wind speeds are going to be 150 at 12 knots or whatever. So let's actually break a TAF down. So this right here is the TAF. So it always is prefaced by TAF, which again stands for terminal air forecast. AMD is a prefix that's sometimes added in there, or a word expression that's added in there if the forecast, that the TAF was amended, which means that the conditions are changing. They usually add that in there. Normally, it's just going to be TAF and then KMSN. So in this case, KSMSN is the designator, the KO identifier for Madison. Again, here's our timestamp block. Again, same as it was in the METAR. You've got your date right there. Zoom in just a little bit more so you can see this. So you got your date right here. You got your time that it was issued, which 14:58, so that was roughly 10 o'clock, right? And then right here, we've got the times that it's valid for. So this one's a little bit more difficult to interpret. When you look at it, it makes sense. So the date or time range is from the 4th at 1500 Zulu. So this is it saying that this report, this TAF report, is valid between these dates and times. So 04, that's May 4th at 1500 Zulu, 10 o'clock, to May 5th, 12 Zulu, which is going to be 7 o'clock tomorrow morning. So that tells us this particular TAF is going to be valid for those times. The reason why they do that is because you may print this out and take it with you on a flight, or maybe you're looking at a bunch of reports. If you see that it was issued 3 or 4 days ago, well, that's not going to be valid. So it's up to you to kind of interpret it when you look at those TAF reports to make sure that you're getting the right information and you're you know, it's current on there. So in this case, it's giving us the date, time that it was issued, and then the time that the forecast was valid for. It's saying from 1500 Zulu today to 1200 Zulu tomorrow. Okay. KT is a dead giveaway that this is a wind element right here. So we can break it down. 150 winds are 150 at 12 knots. So that's how we read that. P6SM. So the P, just consider that plus. It's plus 6 mile statute miles visibility. That's our visibility group. Then we've got our cloud conditions here, scattered at 10,000 and broken at 25,000. So again, perfect day for flying for us in there. However, there's a couple of additional items in here. So this FM stands from. Okay, so what's saying here is from May 4th at 2000 Zulu to 23, or I'm sorry, at 2000 Zulu, which is this afternoon. The winds are going to be potentially could be from the southwest 230 degrees at 8 knots. 4 statute miles is the visibility now, and thunderstorms, open clouds here at 4,000 feet. So that's telling us the conditions at 2000 Zulu. That's again this afternoon. And then tomorrow, they're also giving us another forecast here around at 0 Zulu. And this is actually would be tonight, our time. So on May 5th at 0 Zulu, which is going to be tonight at 7 o'clock, so it's still bad. 320 degrees, 10. Anybody want to take a guess what that G stands for? So we've got turbulent air. What is associated with turbulent, windy gust? Yeah, it's a gust. So what this is telling us, whenever you see this in a METAR or a TAF, it's telling you the winds are again 10 knots, gusting to 20 knots. Okay, that's pretty severe. That is wind shear territory. Yeah.
Does that mean like it varies Or-
Yeah, yeah. And that, again, that could be wind shear. But again, we've got thunderstorms in the area, so that's not uncommon. You know, you can get a lot of wind shear along thunderstorm. P6SM, does anybody know what that means? Kind of, what element is that?
I don't know. It's the
Visibility, yep.
6 century miles.
Yeah, it's plus 6 statute miles. Think of it, the P as plus. It means greater than, but it's just think of the P as plus 6 miles. It's plus 6 miles of visibility. And then this right here, what's that?
Clouds are broken at 2,500 feet.
Yeah, yeah, absolutely. Okay, good. All right, so now you're kind of on your way to understanding some of this stuff. That's, you have to think like a computer, fortunately. So, you know, and eventually, like I said, once you get past your private pilot, you really don't have to use these anymore. I still recommend learning it because there are some times where it's nice to be able to see, you know, you can read so much more weather information with everything encoded than you can by reading it by text. So again, I can easily convert this. If I go back here, again, this is on the X brief site. I switch everything over to plain text. I can read everything out that they had in there. And you know, you can read it verbatim, but look at how much more text that takes out. That little single line of text essentially is now several different lines of text. But it is easier to help you as far as deciphering some of this stuff. So you can kind of go back and forth, but for the test, you're going to want to understand what those contractions, those codes mean on there. So again, this is volt fields right here. Let's take a look at that. So this is all of volt field. Let's take a look at what their coded one looks like. So turn off plain text here. And this is the encoded version of volt field. So much easier to read if you know what the codes are. So this right here, the becoming BECMG stands for becoming, and this is telling you, you know, on the 4th at 16 Zulu to the 4th at 17, variable winds at 6 knots. So what that's telling me is that probably it's calming down before the storm, it looks like, and then temporary between like 1 o'clock and maybe like 5 somewhere there. Looks like they're going to be thunderstorms. That's what they're forecasting there. Overcast. And again, this is becoming from May 4th at 2100 Zulu to May 4th at 22 Zulu. Winds are out of the northwest at 10, gusting to 15 with rain overcast clouds there. So just in glancing at this, you can see it. And the more you do it, the easier it is to read. I realize the first time you look at this, it's like looking at computer code. It's incredibly, it's like, wow, I'm never gonna get it. You will, the more you use it, you'll get familiar with the contractions and you'll understand it. Again, the nice part about it is, you know, after you get your pilot's license, you don't have to do that because there's so many sites that interpret it for you. It just makes sense that you should want to. If you're going on to the airlines, you definitely want to learn these because you're going to need them for, you know, for your ATP, your doing flight instruction, you know, teaching others. You're going to need to know this stuff. So, and you can see I don't even know all of it, all the contractions. There's so many different ones I've never learned a lot of, and of course, some of it's depending on the region that you're in. We not experience certain types of things, like we never have volcanic ash here. Yes.
I was wondering, these are some of your like saved reports.
These are current reports.
I know, I'm just saying these airports, like the whole field Madison area, those three pop up.
Yes, those three pop up because I want to know what the weather looks like in those areas because I typically will fly out of airport.
It's like you have
So-
a bid or something.
Yeah, I'll use those always just because. Well, first off, because not all airports report TAFs, terminal forecasts. So the larger airports like Madison, Milwaukee, Green Bay, they're going to have TAFs there because they have it on staff. They're paying somebody to be a meteorologist at the airport and produce these TAFs. These are human generated reports, the TAFs are. The METARs are typically generated by an automated weather observation station, or what we call AWOS. And they're observations only, they're not forecasts. So, but I like having those METAR or those TAFs there because it's somebody, I know somebody spent some time putting this together, and they think this is what the weather is. And it is, I trust computers, I really do. I work with them every day, but I would much rather hear from a real person what the weather is going to be than trust a computer report. And again, it's changing. The computers are improving, but I'd still rather talk to a meteorologist to get the scoop of the weather and stuff like that. Okay. All right, so let's go here. So these are the different types of they called like area forecast groups for weather. So we've talked about METARs, which are individual points, observation points on a map. So here we have the AWOS station that generates a METAR, a meteorological report. Madison's produces METARs as well as TAFs. Those are specific points. Now we're getting into what, regional weather. So in this case, these are the different regions where weather our conditions are reported. So, and they typically, the region is going to have somewhat similar weather. So for instance, the Midwest, we're all going to have similar weather when it gets cold, in one of the states here, it's probably going to get cold in the other states as well in this region. Whereas down in Texas, Florida, they have totally different types of weather systems that, constantly, repeatedly hit those areas. So they're in different regions there. So that's why we break it up into different regions. These are the identifiers for the different regions. There's the Boston, Miami, Dallas, Fort Worth, San Francisco, and Salt Lake City regions. Again, they're all broken up just because when they report on weather, or they want to do like a forecast for weather, they don't want to say, okay, well, there's, weather's going to be like this over here, and it's going to be totally different in this region. So we can actually narrow it down a little bit. So we're getting, now we're expanding out our view of the weather area and get a, we'll call it big picture of what the weather is going to be. All right. So let's go here. Let's see. Okay, yeah. So this is one of the reports you're going to come across. This is called a winds winds and temperature aloft, or winds aloft report. And I think, let's see here.
It's on 13.
13. No. Actually, over something here. Let's go back. Yeah, that's let's go back here. So this is on 1310, page 1310, area forecast. So at the very top of the page, it says area forecast. That's area forecasts are again a wide area for like these regions that we were just pointing out right here. They're describing the general conditions and maybe a little bit of forecast on what to expect and for weather in that area. But notice on the very top of the page there, it says area forecast, and then in parentheses it says FA. That's the FA designator, the NOAA or whoever generates the weather there. That's a designator for an area forecast. It's called an FA. But we think of them, and when we talk to other pilots, we say, well, what's the area forecast for this region right here, for the Midwest or for Chicago? But FA is the designator for it. Okay, those are again our text reports. And I didn't see any here. I don't really show this. See if I can look here. I know there's a way to bring it up on those. So essentially what an area forecast is, it's again, it's a wide geographic area, and it's a description of the larger weather elements that are within that area, like front, you know, and when it's moving. So if you look on page 310, I give you an example of Dallas Fort Worth FA on there. I don't know if you guys can see that. I don't have an image of that on here, but again, this is on page 3-10. It's got, again, your date and then the time, and then a synopsis. And this is just like somebody's overview of the weather in that condition or in that area there. So, so it's saying VFR clouds and weather. Synopsis is valid until 13. So again, the date would be 13/004 Zulu. So 0400 would be the time Zulu, or 400 Zulu. So clouds and weather valid until, so that's the header element that tells you essentially the region that it's in. Let's see here. Yeah, they actually do a fairly decent job of describing these here. So I would recommend just kind of going through the book on this and reading some of this stuff here. Unfortunately, can't find where that would be at. They've been replacing it. Seems like a lot of this stuff with charts now. We don't necessarily see the text. And I think a lot of these like forecasts and things like that are being replaced with graphics. Now, there are certain types of text products that you're going to want to be aware of. So there's the area forecast. Again, that's for an entire region, kind of a synopsis. There's what we call airmets. Airmets, or quote unquote WAs. That's the two-letter designator for airmet. Those are like in-flight weather advisories for mostly for private pilots, for small aircraft, light aircraft. Okay, and they're issued like essentially every 6 hours. This is on page 311, by the way, on there. So an airmet, and this, you want to know this. Airmets include forecasts for moderate icing, moderate turbulence, sustained surface winds of 30 knots or greater, and wind speed, winds widespread areas of ceiling less than 1,000 feet, which would be IFR conditions there. So that's an airmet. Again, it's not, so that wouldn't be a problem. Those types of things wouldn't typically be a problem for a large jet, commercial airliners. So airmets think think of airmets as warnings to light aviation aircraft or general airmen. You know, not necessarily commercial pilots flying large aircraft. Although they'll still look at them, but airmets are more kind of an announcement to general aviation pilots. They're just warnings there. So. So there's different types of airmets. There's Sierra, Tango, and then Zulu airmets, and each one of those has certain types of meanings to them. So Sierra is for IFR conditions. So if you hear,
There's a 25 votes for this.
oh yeah, okay. So this right here, this is what Donnie's talking about right there. So temporarily on May 4th, from 1500 Zulu to May 4th to 2200, they're forecasting IFR conditions. So again, that's probably because of the thunderstorm through there. And the thing that makes it IFR is this right here. You guys know what that means right there? Let me tell you what that is.
Pumpkin.
Yeah. Stands for cumulonimbus So towering, you're gonna have lots of cumulus, towering cumulus clouds. So definitely would be something you'd want to watch out for. But yeah, for air vents though, that they're just, again, an air vent is for a wide area, and they're saying that if you have an air vent Sierra for, let's say, the Chicago region, then I would expect there to be, IFR conditions in the Chicago area, somewhere around there. And if you look at, they've got an example of it here, and they actually decode those examples. But again, read through these. I won't go through them because it takes too long to describe all that stuff. We really want to keep moving here with that. So that's the Airmet Sierra. There's also Airmet Tango or Tango Airmets. Those are for turbulent conditions. So if I see a Airmet Tango, I'm going to be, for the Chicago region, I'm going to expect there's probably going to be some turbulence in that region that we were talking about, in this area here. It could be over here, maybe it's not going to affect us in Wisconsin, but usually when they forecast a condition, it's for a wider area. It's not going to be like just turbulence over North Dakota or one little spot up in North Dakota. It's usually going to be over a wide area on there. So that's, air vents are going to describe, again, for a larger geographic area. Whereas a METAR is one specific point, TAF is one specific point. Okay, so the other one is Zulu, and that's for icing. Icing conditions. And that's, again, if I saw Airmets on Zulu for this area right here, I would be very concerned because icing can bring down an aircraft really fast. I would want to find out where it is. Maybe there's a front over here and there's enough moisture, it's producing some ice, but I'm flying over to the east here. So in that case, it shouldn't be affecting me if I go up there, but I'd have to read the Airmets here, get information to know where exactly that is. And again, I'd also look at pilot reports. There's a bunch of pilots flying from over here and they run into ice and I'm flying into this area. Yeah, I'm going to be concerned. I don't want to run into ice in place. I don't have the icing equipment.
Those little like red circles on this map, just like major geographical.
No, they're
like
these.
pressure.
Yeah,
it's
they just describe a geographic, smaller geographic area. But again, in the context of this right here, when they talk about a region, they're talking about this whole area. And they maybe they'll refer to this, air traffic controllers will refer to this area here, or meteorologists will say, the river valley area, there's going to be dense fog in that area in the morning or something like that. So that would be one way, I guess. These a lot of abbreviations in weather reports, and again, it's just one of those things as pilots we kind of have to get used to, get comfortable with. So another type of weather report is a SIGMET. SIGMETs are generally more serious for pilots. So there's several different types of SIGMETs. The two-letter contraction for that is WS. Okay, and you can see the definitions on 13-12 SIGMETs. WSs are in-flight advisories concerning non-convective weather that is potentially hazardous to all aircraft. So that means, jets, like large passenger jets, they would be concerned with SIGMETs, and they'll try to avoid them if they can. So they describe it very well. There's different types of SIGMETs. There's convective SIGMETs. A regular SIGMET, it doesn't show convective. Does anybody understand what the term convective means? Yes, it means circulation, right? Think of convection ovens, but it basically means, the convection of the atmosphere they're talking about. So, general SIGMET by itself doesn't talk about convection. It's just basically talking about other things associated, like things like, what we got here, thunderstorms are not associated with thunderstorms, or turbulence, clear turbulence. Let's see. Yeah, so they would, gosh, let me stay here. It'd be like an amplified, I guess, an amplified Airmet. There are going to be concerns that you have, like scattered areas of or complete coverage of IFR conditions or major icing conditions, things like that. We'll see it, but it's not going to be necessarily associated with thunderstorms. Convective segments, on the other hand, those are going to talk about thunderstorms. That's what a thunderstorm is. It's convection building up. So you've got lots of convective currents. So convective segment, if that goes out, and I see that from my region, I'm going to be expecting, thunderstorms. So there's probably convective segment, as a matter of fact, issued, for the weather that we've got coming here today. So,
Dark right now.
yeah. So yeah, we're gonna get hit here in the next. So, yeah, it's and again, you could have predicted that too if you would have looked at the reports there and kind of know where everything's moving. You could see that cold front moving in. So yeah, it's going to be pretty intense here. So again, convective segments, that's a major alert for you as a pilot. If there's convective segment issued for your region, you're going to want to know exactly where it is. Now, right now, the convective segment is probably over this area, for this area right here. So if I'm in Kansas, I bet you Kansas, maybe there's no weather down there at all. So, but it's still in this area. And the pilots in this area, if they look for, any kind of convective segments, they're still going to see the convective segment for this area because it's covering this whole area right up here, even though they're not in it. So again, everything you have to kind of think about, when you read these reports, you have to look at the locations of them, it's going to affect you or things like that. So, all right. So let's take a look at another big report that you're going to see a lot. And this is the winds and temperatures aloft. Pretty easy to understand for the most part. So you get a winds aloft forecast here. Essentially, this is a typical report for winds aloft. You've got your airport identifier right here. This is Denver right here. I don't know what the EMA is. And then here across the top, you've got your altitude, and MSL altitude, I should say, right here across the top. So 3,000 feet, 6,000 feet, 9,000 feet, 12,000 feet, so on and so forth. And then here we have what looks very similar to a wind direction and speed right here. So if you look at this right here, you've got 2.7. So the winds at 6,000 feet over this location right here, AMA, which you're going to know, let's go to Denver right here, and 9,000 feet over Denver, MSL again, this is. You've got winds 230, coming out of 230, which would be what direction? What's that? Southwest, yeah. So the winds are coming out of southwest at 21 knots. And then this is a temperature, or winds and temperature aloft forecast. There's our temperature, -4 degrees. So at 9,000 feet over Denver, the winds are out of the southwest at 21 knots with a temperature of -4 degrees, or 0.4 degrees. And at over Denver at 12,000, the winds are 250 at 32 knots. And it's getting colder. It's now -8 degrees, 3,000 feet higher. Now, you may ask, why are these blank right here at 3,000 and 6,000? Does anybody know why it would be? Yeah, there's nothing. Yeah, it's dirt. Yeah, so at 3,000, Denver is at what's the altitude? Denver, like 5,000 something. Yeah. So 5,000. So at 3,000 feet MSL, you'd be in the dirt right there. So that's why it's blank. At 6,000 feet, yeah, you're just slightly above the airport there. But these are winds aloft forecasts. They're not surface wind forecasts. So they report in thousands of feet. So that's why that's blank. They don't report it there because you can just look at the Denver METAR and actually get the current winds, which are going to be more accurate than this. Again, this is based on observation that aren't done as often. Now they still, believe it or not, they still do winds aloft. They do more of it now with the Doppler radar, I think. But they still send out those radiosonde balloons. They'll send them up in the atmosphere to get good sounds for the weather, the winds, and the temperatures and things like that. So that's why in the old days they didn't have much of this. Nowadays the computers will interpolate between all the different weather reporting points, the winds and stuff like that, and they'll tell you the winds over variable. They'll just say, yeah, if you're flying over variable, these are the winds you should expect on that, and that's based on computer modeling and stuff like that. And then I'm sure with the Doppler radar, they can detect some of that as well. So let's keep going through this just to make sure you guys understand this. We'll keep going up to 18,000 feet because there is a question that's on the test, and I'm sure you'll probably see it. Actually, oh yeah, well let's go through it. At 30,000 feet, what's the temperature at in Denver or at Denver at 30,000 feet?
Negative.
Yeah, good observation. Yeah. So again, Donnie picked it up right there. This right here describes the weather report. It says right there, temperature's negative above 24,000. So we're above 24,000. Notice there's no minus sign there. So don't make the mistake of saying that it's 47. Temperatures are always cold. When it gets in the upper atmosphere, it just, there's not as much heat up there. And so it's always cold. And again, this is in Celsius. So, oops. So here's another example of a weather report. So again, we'll look at Denver. Let me see if I can, oh yeah, here's a good one right here. So this is St. Louis. Let's go through this one. Let's see. Okay, so winds at St. Louis, and again, that's closer to sea level here. Winds are, you guys tell me, what are the winds here at St. Louis at 3,000 feet? What direction are they out of? Southwest. Okay.
100.
Yep. And the temperature? Degrees Fahrenheit Celsius. Okay, good. All right. So, and again, plus indicates positive Celsius temperature. So now everything is as normal, and all of a sudden, we get over here, we get some really bizarre numbers. So what does this mean right here? You might want to take a guess. And you probably won't get it. It's something that and I think they probably have it on the test. Right. It has to do with wind speed. So let's take a look at it. So right now we know the first letter or first two characters of the group is going to be the wind direction. Well, there is no wind direction that is 7.3. 730. There's no such thing as a 7.3 degrees. Well, so you could figure it out, but it actually doesn't exist. What they're doing is, if you look here, let's take a look at let's look at the progression of the winds here. So at 6,000 feet over St. Louis, it's at 25 knots. At 9,000 feet, it's 32 knots. At 12,000 feet again over St. Louis, it's 39 knots. See what's happening here? The wind speeds are increasing. At 18,000 feet, 56 knots. At 24,000 feet, the wind speed is 73 knots. And at 30,000 feet, at 30,000 feet, it's 94 knots. Well, at 34,000 feet, do you think it really goes down to just 6 knots? No. So what this 7.3 is identifier is signifying to you is that this right here is actually now in the hundreds. So what you do is you subtract 50 from this right here, and we get 2.3, which makes sense, right? All these directions are all 230, right? So we subtract 50 from this, and we add 100 to the next two characters. That gives us our wind speed at that altitude. That's, again, it's one of those things that you could see. You guys seen some good weather.
Like 3 minutes ago, you could still see a bit of white clouds. Now it's just
Yeah, it's pretty much like getting pretty close to like
it's almost on top
over
of
in the
us.
distance.
Well, let's take a look at it. I'm just kind of curious.
Yeah.
It's pretty dark there. Well, those clouds are still pretty high.
Yeah.
They're moving fast though. So it's my guess is and take a look at the wind sock over here. So the winds right now are out of the southwest right now. When this storm system passes through, that wind sock is going to shift around. That's a characteristic of all wind front or weather fronts. When the front passes, there's always a change in temperature, obviously, but in wind, either direction or speed. And sometimes, most of the time, it's both wind speed. Well, it's actually just use this as a learning experience here. Let's go here.
Still on
Yeah, there should be, let's go here. So this is the current weather map here. Let's zoom in a little bit more. Assuming this is, yeah, notice how, like, there's still VFR, you know, at the Fort McCoy, they're showing VFR conditions. So that indicates to me that there's not like a lot of really bad weather associated with it. There's thunderstorms that are moving in, but they're not like really close to the ground. So that can happen. They could still be strong thunderstorms. Let's turn on the radar here. Let's see what there we go. So that's Gold Field right there. So there's Reedsburg right there. So we're just right now we're seeing maybe this area right here. So it should start getting dark. We should start seeing rain here probably in the next half hour or so.
Yeah,
And then
that's
obviously
about right.
It looks a bit more than rain.
thunderstorm you see in the lightning.
No, it looks like
Lightning,
it
just
doesn't.
or just very
It looks like
heavy
very
rain.
heavy rain. I don't know about thunder.
Yeah, I mean the Eckerwood turns right here. Those are pretty strong returns and even some red in there. So there's some areas of major downpour right here that are heading this way, this direction there. So
Actually, you could see it because it's really dark.
let's take a look at this. So let's actually use this. So I'm going to zoom out. So again, we're right here, right where my hand is right there. That's where we're at. It doesn't show the dot there. But we can see the weather system moving in. Let's look at the SIGMET map. So I'm going to turn on the SIGMETs, and all it's going to do here for SIGMET is it's going to identify the area. So there we go. There's our convective SIGMET. 62 Charlie is the designator for it. It's a convective SIGMET for this whole region here. So it's saying there, you know, obviously there's going to be convection in this area. We're seeing it right through there. The actual observed weather reports there, the radar and stuff like that. And this right here is just a convective SIGMET outlook right here. Again, it's just saying that this whole area is prone to producing, you know, thunderstorms. This right here is a convective SIGMET. It's like a thunderstorm that we're seeing there. So. Let's see here. So let's go. Gosh. All right. So we'll finish up this chapter next week, and then we're going to dive into airport operations and then airspace. So if you can read the next two chapters, and I know because we had to cancel a couple of meetings. We're running late. We were supposed to end today, but because we had to cancel, I think it was like 2 or 3 of the meetings. We're gonna have to keep going on Saturdays. If you guys can't make it to the classes, that's fine. Just watch the videos online, and then at some point, I still need to sit down with you. All you guys need flights. I want to give each of you guys a flight lesson. We'll take your either from the Twinkie or the Cessna 150, preferably the Cessna 150, so that you guys can actually fly it and control it. The Twin isn't the best plane to do flight training. It's just in any case, any questions at all? Okay, perfect. All right, be safe out there, guys.
Yep, thanks.
Yeah, thanks.
This guy almost falls like.
Yeah.
He was like,
One thing I was going to mention to you, so I talked to Logan about maybe getting
It's
teachers out
moving
there
really
and
fast.
songs.
It's getting lighter.
it is.
You know,
A little
do you
bit.
know of any teachers out there in Stock that might be willing to help out and at least watch
Looks like
over
twice as
somebody?
much
If I gave you guys a simulator, flight simulator down there, so you could actually use it to fly.
Oh yeah. Oh yeah, now. Oh yeah, all that stuff's over there now. Oh yeah, look at the clock.
If you think about it, anyway, just let them know. I've got other
And
people that are going to
really
talk to
cool.
some people down there, but we'd like to get a
Wonder
simulator
what
that's
the
going
fuel
out there so
tank
you guys can use it.
Oh, looks like renovations.
What's that?
Probably.
Where did it be like the
Could be
eerie?
maintenance.
Well, no, see, it's like well,
Was that there?
Just sound like
Oh, that.
Yeah.
they're doing it.
The
Maybe.
solitary.
It's like they're reinstalling.